Leetcode problem 2997, minimum number of operations to make array XOR equal to k. So we are giving an array inside the first example, and we're gonna make the XOR operation for all those numbers, and the final result is gonna be 1. But what if the final result is not 1? So for example, the final result is 1, 1. But we need to make it a 1. How can we make it? We just need to flip this bit. Yeah, we flip 1 to 0. Now, how many flips? It's going to be 1. So this is just an example. Yeah, maybe for this example, it's something like 1, 1, 1. Yeah, this is just an example. And my final answer is 1. So how many flips? It's going to be 2 flips. Yeah. So the greedy idea is that if we find a number, do we need to flip it or we need to wait? So for example, the first number is 2. The second number is 1. Yeah. So the second number is 1, it is 0, 1, and the third number is 3, it is 1, 1, and the fourth number is 4, it is 1, 0, 0. Yeah, so let me prepare the paddings of the bit. Yeah, so the final answer is going to be 1. Do we need to check its numbers and flip it, or we need to use XOR operation to check all the bits? Finally, we just need to check which bit we need to flip. So this is just the greedy idea. So the idea is that instead of calculating its numbers directly, we're gonna calculate them all together. This means we need to finish the XOR operation for each of the bits. If it is not possible, we're gonna flip it. Yeah, so this is the greedy idea. Because if we flip this number first, maybe this is not good. Maybe we need to flip it again. So we need to calculate it first, and then we're gonna flip it. Yeah. So XOR operation. This is yeah, we're gonna do the XOR operation for this bit. The first bit is gonna be 0, and this bit is gonna be 0, and this bit, because there is a 1, so it's gonna be 1. Yeah. So our final answer is gonna be 0, 0, 1, because our final answer is k. But here is 1, 0, 0. This means we need 2 flips. So from here we need a flip to 1, and from here we need to flip 1 to 0. So it's gonna be 2 flips. So we're gonna return 2. So this is how we're gonna solve the problem. Yeah. But how can we check how many flips directly? We can directly use the XOR operation of the final result 1, 0, 0 with 0, 0, 1. So XOR operation is gonna be something like 1, 0, 1. And 1, 0, 1, we just need to check how many set bits. There are 2 set bits. This means we're gonna use 2 flips. Because for the XOR operation, if it is equal to 1, it means definitely this bit not equal to this bit. And if it is equal to 1, this bit not equal to this bit. And how many of them? There are only 2. Yeah. Now let's just solve it. I'm going to prepare answer of all those nums. So I'm going to use a reduce with XOR for the nums. And finally, I just needed to return XOR operation with answer and k, but I needed to use a bit count. I needed to count how many set bits. So this is going to be the final, final answer for the problem. Let me just submit it to check if it can pass. As you can see, it passed for all testing cases, and it's pretty fast. And the time complexity is ON, because for here, it is ON, and here it's just a bit count. So the time complexity going to be ON, and going to be 10 to the power 5. Thanks for watching. See you next time.